Okay, in this presentation we are going to look at Project Euler question 7, which relates to prime numbers. We are using Julia version 1.6.1 and we are using Jupyter notebooks. Now, this set of exercises is aimed at people who are new to programming, new to mathematics, let's say first or second year undergraduate students of science, technology, or engineering subjects, something like that. So we're going to sort of adjust the level of complexity accordingly. So there's I could go into more detail on certain things, but I just, for the sake of brevity, want to hit some key points and leave it there. So question seven is, by listing the first six prime numbers, 2, 3, 5, 7, 11, and 13, we see that the sixth prime number is 13. What is the 10,001st prime number? Okay, so there's no way really of telling how many numbers we would need or how big this number is going to be. Okay, so let's just actually look at what we have to work with here. So in Julia there's a package called primes, and there's a lot of interesting stuff there, and if you're interested in following up on more of these Project Euler questions, it's a useful one to have a look at. So we're just going to say using primes. I have it previously loaded. Okay, now there's a key command here, is called a function here is called primes, and the input here is an n, is the ceiling of a range of prime numbers. So if I was to press this button here, this will give me all of the prime numbers less than or equal to 20, less than or equal to the input. Okay, so there's actually 8. Now the thing is, we don't know how many elements are going to be the output. There's 12. 100, I don't know, I'm going to make a guess, about 23. 25 actually, okay? But I don't really know how long this element is, the output is, okay? And I need to know this because I need the 10,001st prime number, okay? So for example, 25th vector element, or element vector, the 25th is 97, okay? So it's hard to work back, so we'll have to sort of come up with a way of doing this. So just actually length of primes 72, okay, is 20. Length of primes 100 is 25. Length of primes 10,000. Okay, so 10,000 is a big enough number, okay, but that only yields us 1,229 primes if we use that as the input to this function. So what we're going to do is have to guess this number here. Okay, so you see the way I've gone from 100 to 10,000 here. Well, I could go up in steps of 10. Let's just put in a intermediate step there, 10,000, 168. Okay, so what I could do here is just start off with a base case of m is equal to 10. Okay, here the default input is going to be n equals 10. Okay, but what I have to do here is set up the magnitude of the input. Okay, so m equals 10, and what if the length of that primes m of m, okay, if it's less than n, the input, the number we're looking for, okay, so if this is insufficiently low, what we will do here is multiply that by 10, increase it by 10 times to see, will that help us? Let's see, does that help us? Not bad, okay. We still need a few more, okay. So that's what it does. It just iteratively increases this until this number here is big enough such that we'll be able to pick out the 10,001st item. Okay, that's essentially what we've done here. So m equals 10, while the length of primes of n is less than n, the input, m is equal to m star 10. Okay, so when we have enough, what we do here is pick out the nth element of that array, okay, of that vector. So if I was to pick out 1001, something like that. Oops, sorry, that's not what I'm doing. So that's our answer there. Okay, So it's essentially just scaling the input up enough such that it's bigger than this value, okay? Or, sorry, scaling this up such that the length here will be greater than this vector here, this input, this index here, okay? That's it, really. So, Euler of 20, Euler 7, we call this command Euler 7. There we go. Oh, I have to run it first. $71. Okay. Euler 7, 1001. There we go there. All right. Okay. We'll leave it there.